So finishing up some examples then. An electric belt sander was built for a 120 volt outlet, so that plugs into your extension cord or into the wall for anyone that's used it. If it draws 11 amps from the circuit, what's the internal resistance? So again, we know the voltage, this is just decoding. And I know some of you are saying, well, I know what to go to right away, and that's fine. But you need to have a fallback if you can't remember what you're supposed to do or you're not sure. So V equals IR, so 120 equals I. Oops, I know what my I is. 11 amps. And you're finding resistance. So just using your math skills here, you divide both sides by 11. And we get 10.9 ohms. So therefore, internal resistance is 10.9 ohms. Now the second part, if the internal resistance of the sander is 25 ohms, what's the maximum current it can use? So really similar question, you know the voltage, and for the most part it's always going to be 120. You can't really vary it because in the real world it doesn't vary, so it would seem kind of odd me changing the available voltage from the wall. And we're looking for a current, so that's the unknown. So again, we're using V equals IR. So your voltage is 120, current is unknown, and your resistance is 25. So 120 divided by 25 gives me 4.8 amps equals 4.8 amps. So therefore, max current is 4.8 amps. All right, moving along. Power in electric circuits. So power is the rate at which work is done. So there's three formulas. Really, I see it as one, but there is three formulas. So I know that P equals IV. Okay, so that's one of your formula, and I'll summarize and put a red box around everything at the end. What happens if we use V equals IR for a substitution? So if I take P equals IV and I replace V with IR, I would end up with I squared R. So there's a second formula to determine power. If I go back to the drawing board here, P equals IV, and I replace the I value, which would be V over R. So V over R multiplied by my V, I would now have power equals your voltage squared over resistance. So there are the three derivations. Like I said before, they're kind of all the same. So PIV, P equals I squared R, and P equals V squared over R. So that's what I'm going to put the box around. Those are the formulas you probably want added to your study sheet or cheat sheet in order to do work through your homework. Okay, so I have a couple of examples working with those formulas right there. So what's the maximum power that we draw from? Again, a 120 volt wall socket, and it has a 15 amp breaker. So this is like a fuse box or your breaker. So you're going down and ask your parents about where the box is and take a look at it. The breakers, there'll be different colors, and you'll have your 10 amp, 15 amp, and there'll be a 20 amp maybe breaker box. And what it does is it allows only a certain amount of power to be drawn or made available. So max power. So I know I have a voltage of 120, and I'm given a current of 15 amps. All right, and I want to find P. How much power can be drawn? Okay. So with that information, I know I have to use, and again, from your red boxes, you're just picking the correct one here. It's just going to be IV. All right, IV. So 120. Oops, I guess I did it in the right order. Not that it matters too much. 15 times 120. You do that calculation. You get 1800 watts. All right, so therefore, max power would be 1800 watts. So I mean, you'd want to hook up something that is going to draw more than 1800 watts from that particular breaker. So if you're looking at an electric motor and you're plugging it in and it requires 2000 watts, that breaker will switch to the off position because it's only going to allow 15 amps of current to pass through it. That's the maximum allowable current it will provide. And if you have something that wants more power, if you look at that formula, P equals IV, well, the V is constant. It has to be 120. That's all we provide in the house. That means your current has to increase. If it goes over the 15 amps, then it shuts down. It won't allow it to happen. And that's what protects us from fire and other catastrophes in the house. So calculate the power rating of a stereo amp. So this is your amplifier. If it's plugged into a 120 volt wall socket, it has a rated resistance of 85 ohms. And if you look in the back of the electronic equipment, you'll find all these measurements. Okay, so if you do have a chance, take a look at the back. So we know the voltage is 120, and we know the resistance in this case is 85. So we're looking for power. So what is the power rating? So going back to your three formulas, you have V squared over R, which is what will connect everything together for us. So power equals the V squared over R. So 120 squared over 85. And what you'll end up with is 120 squared divided by 85. You've got 169. That seems a little low. Divided by 85. Yeah, 169 watt system. Okay, so therefore, if you're looking at the classification of the amp, it would be 169 watt or 170 watt speaker system. So therefore, the amp is rated at 169 watts. There we are. There's the homework in the bottom corner here for you to try. If you have any questions or any problems, let me know, and we'll go through it and make sure everyone is understanding what needs to be understood. Good luck.